Hi everyone, welcome to our next tutorial. Today we are going to talk about RAG. RAG stands for Retrieval Augmented Generation. It's some common task when you deal with natural language processing alongside with other common tasks. As you know, you have prompt engineering, you have RAG as I mentioned before, and you have fine-tuning. Before deep into the detail, let me recall why we're using RAG, why RAG is important. Remember that when you have a large language model, for example Mistral or I don't know GPT-2, these models are not up to date, and when you have some update information, I don't know if you, for example, you want to know the weather, yesterday weather, if you ask to the, I don't know, ChatGPT or Mistral, they will not give you this answer because they was trained on the very whole data or whole data, maybe months ago. And if you want to add this information and leverage the power of your large language model to retrieve, to know the weather of yesterday, you can use a database to add this information into your large language model. It's not exactly, but if you want, you will have your large language model alongside with your vector database. The vector database is the database that will contain all update information, and this information you will pull it into the vector database. First of all, let's explain what is our data set. We built this data set from scratch. They are focused on the tourist site in France. You have 5 columns. The first column is site, the name of the tourist site. You have some famous tourist sites in France. I don't know, you have Tour Eiffel here, Les Invalides, Basilique de Saint-Denis, Dune du Pilat. This is the name. And you have in the second column, region, is the region where the site is located. You have Tour Eiffel in the region Île-de-France. You have here Dune du Pilat in the region Nouvelle-Aquitaine. And the third column is year, refer as the year when the site was built. For example, you have Tour Eiffel that was built in 1889 for the World Fair. You know, you also have a column of rating. Here is called note. You have some rates, some random rate, 3.6, 4.5. we use it in our RAG operation. And you have the last column reserved to reference to the comments. You have some comments of the people who visit this site. As I mentioned before, I construct this dataset from scratch. I make some fact checking. I don't know if it's good, but I think so. Now let's dive into our Python code. Here we use a Jupyter notebook. First of all, we need to import, as you know, our CSV file, and we will transform this dataset into a dictionary type. Why? Because we will load in the next step this dataset into a vector database called Qdrant. And remember that Qdrant only manipulate a dictionary. Let's see how our data set is built. You can visualize some head of our data. This is the head, site, Abbaye de Cluny, Pont du Gard, Cité de Carcassonne, the region, Bourgogne-Franche-Comté, Grand Est, Occitanie, province Alpes, Côte d'Azur. And you have the year, the year of the building, the note, and some comment. And when we transform our dataset in a dictionary, you have this dictionary structure here, sites as key. You have the column as key, and the value of every entry. You have set here, catégorie de Rennes, region, Grand Est, année. You have here note and commentaire. Let's go ahead. Now we will import some useful package. As I mentioned before, we will manipulate Qdrant database. We need to import its client. We also need a sentence transformer. This sentence transformer will allow us to create some embedding. You know, natural language processing manipulate embedding. It's vector, it's number. They transform text into embedding. Embedding is numerical value, okay, and they feed it into some matrix because it's very simple to manipulate. And we set up some transformer. The transformer will allow us to create embedding. Yeah, that is good. Let's go ahead. And here we will create, as I mentioned before, the vector database, and this database is in-memory database. Why? Because I mentioned before, it's a vector database, and the database will be loaded in the RAM, in our RAM. Why? For only the speed purpose. Because when you have your dataset load in your RAM, when you will make some search, here it will be the similarity search, they will be faster. They will be fast to answer. You will get the answer very, very fast. Okay, let's go on ahead, and here we'll create a collection. We'll pass some attribute for our vector, for our data vector. Yes, we have the size of the vector and which distance we'll use to compute our similarity search. Here we use cosine distance. Okay, you know, remember that we are also a lot of other type of distance. You have Euclidean distance, and you have Manhattan, and etc. Let's run this one. Yes, you see here that Qdrant is not defined because we didn't run the previous cells. Let's run it and run that cell again. Everything is work fine. And now here we have our collection that we create at the previous step. and we create some points. The point here is a matrix where we have each our entry of each our site along with their metadata. Okay, and this one is encode. This one is in the form of embedding. Okay, embedding is, as I mentioned before, is a numerical value. Let's run these cells. Everything look fine, and now we will use some prompt. We will ask to our RAG to suggest an amazing site from Ile-de-France to visit. Okay, we can add here to visit. Okay, let's run it. We only define here our user prompt. Now we will make our search in our Qdrant database based on our user prompt. This is what this line of code do. You have a result equal 3, means that they will retrieve only 3 result of the funding. Let's see it. Let's run and see. You have here our answer. As I mentioned, you have 3 results. You have the first site you can visit if you are in Ile-de-France. You have Basilique du Sacré-Cœur, region Ile-de-France. It's matched with our request region, yeah, Ile-de-France. Sainte-Chapelle also match with our query. Moulin Rouge also. We have our result come from our vector database Qdrant. Now we will define variable to hold the search result. Feed this result in the search result if you want. And here from Ile-de-France we have here this part where we will use our large language model as mentioned before, running in the backend. Here we use the Mistral AI. Yesterday, remember I show you how you can run large language model locally. Here what we do, we first of all run our large language model locally. Here it is Mistral 7 billion parameter model, and when our model is running locally, we can now use our model to get some answer. If you want to rearrange our answer having to the previous step. Okay, it's not no if it is clear, but remember that in the previous step our code here only retrieve 3 sites to visit, and this answer come from our data set. And now we leverage the power of large language model to print this answer in the more convenient way if you want. Okay, and that is why we have this code. We use library OpenAI. We don't have a API key. Why? As mentioned, we use an open source model, and we have a message. We roll. You are a chatbot, a trust advisor. Your top priority is to help guide to user to help user into selecting amazing French site to visit. Okay, and a user asks you, suggest me an amazing site from Ile-de-France to visit, and you will have an answer. Okay, let's run it. Sorry, it will take some time because the model is run in the background. The large language model, it's very quite fast. Why? Because you have only 7 seconds take to running, and this is our answer. Basilique du Sacré-Cœur. This stunning basilica is located at the highest point in Paris, Montmartre. Its white marble facade and intricate detail make it a must-see attraction. The interior is quite impressive. You know, this is very amazing. You have a good answer, a very performing answer. Let's see it in the more convenient way. You see, you have 3 proposals. The first one is Basilique du Sacré-Cœur. This stunning basilica is located at the highest point in Paris, Montmartre. Its wide marble facade, its intricate design make it a must-see attraction. The interior is really impressive with beautiful stained glass window and a very long text here, so you can reduce it. A breathtaking view of the city from the dome. You know, you also have here Sainte-Chapelle. This historical site is must visit for anyone interested in architecture and history. Sainte-Chapelle is famous for its stunning stained glass window which feed from the chapel. And you also have Moulin Rouge. The Moulin Rouge is a legendary cabaret and symbol of Parisian nightlife. This iconic building is famous for its can-can dancer, the French can-can, you know, an extravagant show. Maybe to Moulin Rouge is a must for anyone looking for authentic Parisian experience. You have the ranking for 0.2 and the comment absolutely worth seeing. Alright, this is the end of our RAG tutorial. You see here how you can leverage the power of large language model alongside with a vector with a database, a vector database, where we load our up-to-date information or our private information, because as you know, if you don't want to expose your data to internet, you can use this way to set up your RAG. Thank you very much and see you later.